Hey guys, it's Mike from Shimino's Workshop. In the middle of a batch of Sabre installs, and I thought I would start doing some tutorials, some video tutorials as I build this Sabre. And I'm in the middle of soldering and preparing to wire up these ShtokCustomWorx Dimitri stock, his NeoPixel PCBs. These have 5 NeoPixels on board and 11 pogo pins. You can see here when you buy these from Sabre Bay. Who else sells these? Well, I guess you can buy them directly from Dimitri. Sabre Bay, maybe KR Sabre stock these now too. I buy them from Sabre Bay, being in the US. They come with short pins, they come with long pins, they come with 470 ohm resistors. I think that's an 0402 footprint, so really small. And they come with blade side adapters as well as the hilt side adapters. Most of the time I'm just using hilt side, and so I've amassed quite a collection of these extra blade sides that maybe I'll just start selling at some point to get rid of. I literally have, I probably have 100 of these things, and a bunch of these 470 ohm resistors, because they give you like 3 or 4 of them in each set, and I generally only use one. Alright, well, with that said, the first thing I do, these PCBs usually come, they come disconnected just like you see, but they still have some leftover material from when the PCBs were connected to each other, because, you know, these things are printed in mass, and I don't know, maybe these blade sides have them. Yeah, I don't know if you can be able to see that, if it would, but right here along the top you can see it. So unfortunately you've missed it, but I usually take my Dremel, and you're gonna have 2 of them on each one. So I take my Dremel, any old Dremel with a drum sander on it will do, and, you know, use the speed that you're comfortable with, and you're just going to sand it down just a little bit, right? Don't touch the LEDs when you're doing it, but just sand it down nice. If you're worried about using the Dremel, then maybe a little bit of sandpaper down on the mat, and you can do it like that and just kind of roll it. So that's kind of step 1, right? Is just kind of preparing the hilt side adapter and, you know, sanding it down, making it circular. Because at the end of the day, they're going to fit inside of some device like this. And, you know, so it needs to be circular so that it fits in there. And the extra PCB, I don't know, the remnants of it all being in the same board gets in the way. Okay, so that's kind of part 1, right? Part 2, and I've already done this, but I use a little bit of flux. I use that. Just pick that up at Home Depot or Lowe's. Are there better alternatives? Sure. And what so these can support 4 different configurations. I happen to use version 4, which requires, so version 4 allows the 5 PCBs to be styled differently than the blade pixels would be. So in order to do that, you would run 2 data lines, one to data line 1, which is the very middle hole, the center hole, and the other is data line 2, which would go to this pad that I'm pointing to. But in order for that to work, just like you have to resistor your data line 1, well, at least on Profi version 1.5 you did. In Profi 2.2, data pad 1 is already pre-resistored on the Profi board itself, so you no longer have to have that inline resistor for data 1. which can also be taken care of usually on the blade side. So here on the blade side PCB is where you would usually drop your resistor. Let's put that down there, maybe we can let it zoom in. But usually you would bridge this, or even on a custom Saber shop, you would bridge the Data 1 pad with a 330 or 470 ohm resistor, with Profi board 2.2, maybe even with CF10, CFX. You may not have to do that. But with these, they give you a pad to put an 0402 resistor with the resistors they give you. If you're already pre-resistored further down, like say on the Profi board itself, for whatever data pad you're using, maybe you have an inline resistor, then you just bridge these two pads without a resistor. You know, maybe use like a stem from a resistor, just cut it off and just bridge those two pads. But for me, what I do is, you know, I do these in batches. So I have the Heiko soldering station. I tend to solder a little bit hotter. That's 725 Fahrenheit, which is, I don't know, that could be 350 Celsius, maybe 400 Celsius, which is a little on the hot side, but as you get experience with soldering, you know how much heat to apply for how long, as to not damage any of the pads or any of the electrical equipment. So what I'm doing is I'm tinning with just a little bit of solder. So I'm pre-tinning the tip of my solder, of my soldering iron, and then to make sure I don't block the camera view while I'm doing this. And then what I'm doing is I'm just holding with my hand, and then I'm just touching the three pads. So as long as your soldering iron is pre-tinned and you have it hot enough, I'm literally kind of just dragging the tip of my soldering iron across the three pads. And because we have flux and a good amount of heat, I don't know if this will, let me see if I can force the zoom. But those three pads get tinned, and if they don't get tinned adequately enough, I'm looking at them, you can always just run over those pads again. So for example, I would just pre-tin a little bit more and then just hit the pad very quickly, boom, and then you can clean it up. With some practice, you get it right the first time. So I pre-tin all of them. Just gonna move through this a little quickly. And then on the last big one, you don't want a lot, especially on the smaller pads. On the smaller pads, you just need a little bit. It'll make sense why later, once I show you the technique for putting the resistor on. But if you put too much solder on those small little resistor pads, then it makes it more difficult to put the resistor on. You kind of want it to be a flat surface, and that's why I like this sort of wiping effect or style of applying the solder on those pads, right? Pre-tinning the tip, putting the tip onto the resistor pad, and just kind of swiping. And if you use enough, as you can see, not only did my two resistor pads get soldered, but it also, the heat or the solder transferred to the data pad. So same thing. I'm going to kind of swipe across. That time I didn't touch the data pad, so nothing transferred. So just a little bit more. Okay. Always get into the habit of, cleaning your soldering tip. I'll bring this over, right? So we have this, so you want to get in there, you want to clean it. I don't use the sponge with water. I have a tendency to just sand the tip and then use like a tip tinner, something like that. So to clean, so instead of putting the soldering iron tip into water or the sponge that's wet to help clean it, I'm just using like this stuff. I buy a pack of these from Amazon. You can, jab the tip of your soldering iron into it. That helps to remove, sometimes you get if you're soldering wire or you're desoldering, right? You get remnants of old solder or wires. You get material on the tip, so that helps to clean the tip. And then, if you get too much buildup on the tip, then I just use maybe 400 grit sandpaper and sand the tip, both sides. I have a tendency to use a flat tip, a small flat tip. So I'll sand both sides, and then after it's sanded, I just kind of dunk it into the tip tinner, and then clean it off on the sponge. Not on the sponge, but on the bristly, kind of like cotton, like a steel wool almost, but it's not steel, it's brass or gold or whatever it is. Okay. So step one, make it circular, clean up all the old PCB traces. Step two is a little bit of flux on the pads that you're going to solder. Step three, tinning those pads, pre-tinning those pads. And so now step four, I'm going to put some of these aside. So this is a tip that we watch Mad Cow on the Custom Saber Shop. He has some videos if you go into the NeoPixel section. And, he's demonstrated this tip using the Custom Saber Shop PCBs, and it works great. So a little bit of masking tape just to hold the PCB down. And now we're going to crack that open. So these are the 470 ohm resistors. Am I in frame? Yep. These are the 470 ohm resistors that come with a set of these PCBs. So we're just going to take this plastic covering off and let the PCBs fall out. Not the PCBs, but the resistors will fall out. Very small. I don't even know if you'll be able to see them. And so what we're going to do is we're going to lay them face up. So this black side up. Okay. Let me frame there. Hopefully you can see that. I'm zoomed in all the way, guys, so sorry I can't get any more. And then we're going to take just another small piece of masking tape. And we're going to, let's see if we can, yeah. So what if I zoom out and then come close? No. But I'm picking up the resistor using the tape, and then I'm placing the resistor onto the top pad, right? So the idea is that the tape will hold it in place, right? So here's the resistor. If I pick that up, I think I just, yeah. So if I pick up the resistor with a pair of tweezers, right, we're essentially doing that. Hopefully you can see that. And the masking tape is holding it to the board for us. Just going to get these out of the way. And now, again, I'm going to take my, I'm going to pre-tin. Just a little. And I can't even see it. You know, they're so small. But I know where that pad is, so I'm just going to zap the pad with a little bit of solder. See, and it didn't catch. Of course it didn't. Why would it? Okay. But the idea here, and sometimes mentally I'm counting to like 2 or 3 in my head for you know, for how long I want to apply heat. I'm gonna hit that pad again with just a little bit more solder. Okay. And then you can kind of use, so as you can see, when I folded back the tape, the resistor lifted off. That knows, so that means I didn't get a good soldering joint or connection. And so now, but now when the tape is lifted off and I can try, oh, you see it popped off. So it's not good. It was not a good, you know, I'm not even going to use that resistor. I'm going to blame the resistor, guys. I'm going to toss that resistor over there and we'll use a different one. Okay. Okay, so I'm going to hit that again. Give it a second to cool off. So now the top of the resistor is soldered to the top pad, and now I'm just going to come to the bottom pad, or to the, I'm going to come to the top of the bottom of the resistor, and I'm just going to let the solder do its job. Now I'm going to lift the tape up. I'm going to visually inspect it. I don't like how this one came out. I'm going to put that aside and come back to it. And I'll probably redo it, or you know, one of the next steps after I get these resistors on, I'm using my multimeter and I'm checking 1 for continuity and 2 for resistance. So we'll come back to that one and make sure using the multimeter that it's in fact soldered properly. So I'm gonna move on to the next one here. Okay. So same thing, tinning. 1, 2, just quick touch. That one I got laying flat. So now I can just hit the bottom pad, a couple seconds. So I know you can't see me doing it, but I'm taking it off the camera. I'm just visually inspecting it. You know, my eyes are okay. I haven't really lost the ability to see these small things. And if you do, you know, picking up a good, maybe a set of magnifying glasses, you know, something that you, like a doctor or an eye doctor would use, somebody that does fine jewelry. You know, they have those head sets that have the magnifying lens that you can put in front of your eye. Maybe pick that up at like Harbor Freights. They're pretty cheap. And then you can, you know, get a good visual inspection, make sure that you approve of your solder joint. I'm going to go grab my multimeter. Sorry for the background noise, it's my 3D printer. I'm printing some stuff. So I'll just show an example here. So I have this particular from Klein Tools. I probably picked this up at Lowe's, maybe it was Amazon, I'm not sure. But I'm bringing it to the continuity test first. And this is probably overkill. But what I'm doing is I'm checking continuity between the data 2 pad and what was the top, right? Because I was going this way. So the data 2 pad to the top of the resistor, and just making sure I hear a beep. So that tells me from the data 2 pad to the top of this resistor, I have continuity, which I should. There's really there shouldn't ever be a case where you don't. Then I'm changing it to resistance. So you know, the sound is continuity, and then this, if I hit the selection, it changes to resistance. And so now what I can do is from my data 2 pad to the bottom. You can't do continuity between the resistor because of the resistance. So what you do is I'm checking to make sure that I'm getting, and let me bring the multimeter there. I'm checking that I'm getting 470 resistance from the data 2 pad to the other side of the resistor. And there you go. What did it say? 470. Hard to look at both things at the same time, but there you go, 470. So that's perfect, perfect resistance. So I know that resistor is on there, it's good, I'm getting the right resistance. I'll check the other one that I didn't necessarily like. I'll check resistance first. 471, close enough to rock. So while I don't necessarily like the job I did on that resistor, it's proper. So I'm going to, I'll probably pause the video because now the next step is putting the pogo pins in. So I'll pause the video, I'll do the remainder of these, and then we'll come back and we'll continue the tutorial with putting the pogo pins. Putting them in, soldering them in place, and then later we'll wire them. Okay. Okay guys, so picking up where we left off. So I finished putting my resistors on, I finished checking the resistance value between the data 2 pad and the inside part of the resistor, and I'm making sure I'm getting 470 ohms. That lets me know that I have applied that properly. And so now we're ready for the pogo pin. So I'll just demonstrate this on one of them. So we'll get some of these out of the way. So usually, not all the time, I'm not sure what determines this, but usually when you order these, you're going to get a hilt side, a blade side. You'll get one of these that have the word press on it, and you're going to get 11 pogo pins. From Saber Bay, if you order them unassembled, then you'll just get them as I showed you before. If you get them assembled, they'll attach the pogo pins, but there's no option to tell you, am I doing version 1, version 2, version 3, version 4. So I'm not sure that they apply the resistor. And if you have the pogo pins assembled for you, it's going to make it difficult to apply the jumper or the resistor, 0402 footprint resistors, if the pogo pins have been soldered on already, at least using the technique that I use. So I get them all unassembled because I'm buying these in bulk, and I'm assembling them using either the long or the short pins, depending on the build that I'm doing. So here we have the LEDs face up. Sorry, LEDs are face up. So I want to be looking where it says the word hilt, and I'm going to insert the pogo pins from that side. So now they don't, they don't press. I wouldn't say that they press fit in. They just kind of drop in. Sometimes you got to give them a little push down, depending on the, I guess, on the trace. Like that one I had to push in. Not hard, it just doesn't drop in all the way. So I'm just dropping the pogo pins into place. They won't fall through, right? Because the foot, I guess we can call it, the foot of the pogo pin is larger than the hole, which makes sense, so that they don't drop through. Okay. Now the idea is I'm going to add solder to the top of each of these pogo pins so that they stay in place. The problem though is with these long ones, you see there's movement. Even, right, you see how how it wiggles? So if I were to just solder that now, they might not be straight, and it would make it difficult then, if they're not perfectly straight. One, it might make it difficult to put them in through the holder that you might be using, and two, if they're really off, then they might not make connection with the blade side PCB, and then that ruins everybody's day. So I forget, so these have to be oriented. So that's where this press fit piece comes into play. I'll move the hobby thing out of the way. The idea is I'm going to do something like this once I find the right orientation. Okay. So that's your orientation. So if looking at it, you have the word hilt on the top, and then I turn it over. So there you go. So Dimitri's logo, which is now on the bottom. If I flip it over, Dimitri's logo, they're not perfectly lined up, but Dimitri's logo sits over one of the LEDs, which is over the BP foot text, the blade ID, the blade pin, BP, blade pin. So blade pin is oriented with Dimitri's logo on the press PCB. So now that helps to keep the pin straight as I solder. So now I have this little hobby vise. Again, I think this was a Harbor Freight. A couple of dollars probably at Harbor Freight. And we can either use that. I tend to use that when I'm wiring. Otherwise, I don't know if you can see there, I have my little hands thing, which is magnetic, and to my little quick hand thing. So I prefer the quick hand. It just gives me a little more space to work. And then I get it situated the way I like it. Move the camera over a little bit. Sorry that this is not so professional, but so now that I have it where I like it, again, a little bit of flux, and I'm just gonna brush it over to contact the pogo pins. Okay. Now I want to make sure, I'm just going to visually inspect the pins, that they're all the way through and sitting flat. And now there's a couple of ways that you could do this. Again, I'm going to pre-tin. Now the first couple might take a little bit longer for the solder to adhere properly. But as the PCB heats up from you soldering all 11 pins, it goes quicker as you get through them. So two methods that I kind of alternate with, just kind of randomly. Pre-tin with, you know, a good amount of solder on the tip, and then I'm just putting it on the top of the pad, and maybe 1, 2, 3, and that's it. I counted to 3. The solder adhered and cooled off, and then I can do the same thing. 1, 2, 3. So that's one approach, right? Is to kind of pre-tin the tip with enough solder, and then touch the pad for a 3 count, and your solder should be applied. So we can continue with that approach. Or, now that the pins and the board itself are starting to get hot, the alternative is to just touch it and then apply the solder. I don't like that approach. One, because if you have shaky hands, right? I'm exaggerating, my hands aren't that shaky, but if you have a shaky hand and then your other hand is shaky, you might get solder across multiple pins or multiple pads, and that's not very good. So I tend to pre-tin, and then 1, 2, 3. And that seems to be the right amount of solder for the right amount of time, the right amount of heat. And then I'm just rotating as I go around. Okay, again, making sure that the pins are pressed down. Still on camera. So, you know, that's the downside of using the helping hands, is that sometimes it falls. But I find doing it in the hobby vise, the sides of the hobby vise get in the way, and I have to rotate it around anyway. So really, what's the point? Okay. Okay, and now again I can go and I can visually inspect. If I don't like this bottom positive pad right here, if I don't like the way it looks, I'm just going to add more solder to my tip, my iron, and I'm just going to hold it there 3 seconds. And I'm visually inspecting. Cleaning my tip, and now I'm just bouncing it up and down. Just checking that they're all in. You know, sometimes you don't have a good solder. If it's a cold solder joint, the pin will pop out. I've definitely had that happen to me. So just testing the action of the springs, making sure nothing's popping out, doing a visual inspection. Things here look good to me. So I'm going to take the press piece off, and you know, you could then, I don't have it with me, but a little bit of, you know, you can clean the solder off. A little bit of alcohol, rubbing alcohol. not the solder, the flux. Clean off the flux. So this one's now ready to be wired. The way I wire them is I run a single 22 gauge to positive. I run 30 gauge to my data lines. So data 1 is the center, data 2 is by my resistor, and then I run two 24 gauge wires for my negatives. And I'm not installing blade ID detection, so you need to bridge the blade pin with a negative pin, because the blade pin right now, this BP, this pin here, is not connected to the negative, to any of the negatives. So that's just a feature that the Profi board supports. I'm sure CF10 supports, that allows the Profi to know if a blade has been inserted by detecting, I guess, voltage flowing through that pin. If you don't want that, then you have to bridge the blade pin with a negative. So what I usually do is one of my 24 gauge wires, I'll make the I'll make it long enough that it spans across these two, and then I'll solder that wire to both of those pins. And then the other one I usually go right here to this negative pin. And then the positive can go here or here, right? The positive is all the outside ones. So I can go to any positive one. And then I'm going to check continuity. I'm going to make sure that, and we can show that now, but I'll show it again later after we do our wiring. This might be a little difficult to demonstrate. Okay, and we're on camera. So it's just in continuity mode, so it's going to beep. But the idea is that I'm touching one of the positive pads that I just soldered, and then I'm touching all the other pins, and I should only get continuity on the outside pins that are positive. The data 1 pin should not be beeping, and my negative pins should not be beeping. So that at least helps me confirm or validate that I didn't solder two pads together, right? I didn't bridge the data pad with a negative pad or a negative pad with a positive pad. So I'm just doing continuity to confirm. And then, but I'll usually do that after I wire. So I'll come back later after everything's been wired. I'll attach, I'll clip. I'll use the clips on my multimeter to attach to the wires. And, so put this on the positive wire and then use the negative to touch each of the pins and make sure I'm getting good continuity. So we'll come back to that. So again, I'm going to pause the video. I'm going to apply pogo pins to the rest of these, and we'll come back and wire one up. Hey guys. Okay, we're back. I just had enough long pogo pins to do 3 of them. I have a stock of short pins, but I had to order some long pins. So we have 3 of them, but for demonstration, I'm just going to do one of them for now. So I do use my hobby vise for this, and what I do the data 2 first. So I get that situated towards the back, I guess you can call it, of the vise. And I've also pre-stripped my wires. So this is I use 24 gauge, I use PTFE wire that I get from an eBay seller, Empire Don. He has a store where he sells military grade, military spec PTFE wire. This is where I source them from. It doesn't have to be him. You can get them from many different places, but I also know the length that I need for the particular install I'm doing, so I've cut them to pretty much the same length. So I have red is my positive 22 gauge, I have two blue 24 gauge that I'm going to use for the negative pads, and then I have 30 gauge for my data lines. Usually what I do is white for data 2 and then blue or some other solid color for data 1. So for me, I'm going to do the data 2 pad first. Now this wire is pre-tinned, stranded, pre-tinned, but what I like to do is I just add a little bit more, helps keep the strands together. And now that's way too big, but that's what I do is when I you know, strip them, so I use Klein tools to strip them. This particular tool goes from 22 gauge to 32 gauge, so that covers pretty much the spectrum that I deal with. And then I'm clipping it pretty short. I don't keep a lot of the wire. I don't know, maybe that's an eighth, maybe it's somewhere between a 16th and an eighth. And then just a quick 1-2. Wait for it to go from that nice silvery to that sort of, well, I don't know what you would describe that, but I know that's a good solder. And then I move it out of the way, because then the next thing I do is my data 1, which is my other 30 gauge. This time it's blue. So again, tinning my wire just to keep the strands together. Then I'm stripping it down. Just to keep it short. And now the same thing. I'm going to hold it over the data pad while I apply some heat. Now I'm at 700 degrees Fahrenheit on my soldering station, which is more than enough heat. Really all you need to be able to do is melt the existing solder, which takes maybe 2 seconds at this temperature using the solder that I am using, and it melts and then obviously cools down, and then I'm good to go. Now I'll loosen and kind of turn. Just what I want to do is make, because like I said, I'm bridging. See if we can lift that up to the top a little bit more. I'm going to bridge. So I've stripped one of these wires a little bit longer. Yep. As you can see, I've got a long bit of wire exposed. So again, I'm going to pre-tin. Now, like I said, this wire that I buy is already it's tinned, which just means that it has a layer of solder on it already, and not just wire. They're not just wire, but I pre-tin it, and so that's doing two things for me. One, it's keeping the strands sort of locked together so the strands don't kind of come apart. And two, the solder on there is going to melt with the solder that's on the pins, and those are going to kind of melt and infuse together. So now I can just lay that across the blade pin and the negative that's next to it. I'm tinning my tip, and then I'm going to try my best to kind of lay that across both pads. So the wire is bridging across. No, I had to redo that because I don't know how well you guys can see that, but I bridged the negative pad with the data pad. So that's, you know, that's what you got to be careful. Okay, so that looks good. So now those two pads are bridged together. And that's one 24 gauge that's going to go back to one of the LED pads. And now I'm going to do the same, well, not the same, but I'm going to tin my wire. Cut it back down so it's a little bit smaller. It's a good size. Now I'm going to hit one of the other negative pads. Okay, just enough heat to melt the solder. And don't overheat it. Okay, and then last we have the positive. And then the same thing. Trim it back. Now the positive ones are a little interesting because they're so close to the outside, right? It's a balance between using one that's, you know, away from all the other ones, maybe, just to make life a little easier, but also you don't want it too far on the outside because then it makes it a little more difficult to sit it in a holder, especially if you're going like a thin neck saber. For me, for this install, I don't really need to worry about where the positive wire is. So that's that. Okay. So now I can unseat that from the holder. And again, just a visual inspection. Give a tug on the wire. Make sure it's not going to come off, especially the data wires, because they're so thin. You know, you don't want to move or pull them too much. But you know, just a quick visual inspection, maybe bend them up, maybe twist them, braid them together. Pretty happy with that. Okay, and now my tails have also been stripped. Now the reason for this, I haven't tinned them though. They've been stripped so that I can do a test. So there's a couple of things that we're going to do. Like before, where I mentioned we're going to check for continuity now. Let's put that in there. And now I'm taking my meter, I'm putting it into continuity mode, not resistance, but continuity. Okay. We'll start with positive. I'll put that onto the positive here. And now I'm going to use the negative, and I'll move the meter out of the way. We're only looking for a beep. So I'm connected to positive, so I know my outside, there's 5 outside positive pins. They should all beep, because they're all internally connected on the PCB. So one wire, I should get beeps on all 5 of the positive outside. So that's good. Now I'm checking for shorts. It shouldn't beep on the 5. 1, 2, 3, 4, 5. That was me touching a positive. So negative, 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 no beeps. Positive beeps. My data pin, no beep. So I got good continuity on positive. Now it might be a little overkill, but you could do the same with all the other wires. Really shouldn't be necessary, but I can I'll join my 2 negatives together, and then I shouldn't get beeps on positive. I shouldn't get a beep on the data. Nothing, nope. That's data, good. And then my negatives should all beep. Good. Now, I can test my blue data, because that's the middle pin. And this one gets a little tough because of how thin the wire is. But I should get a beep on my data. Nothing on the negatives or the positives, so I know I'm good. Okay, so that's the test that I do before I now test functional. I want to see the lights. So I built this rig that I use in testing my blades. So let's see, let's zoom out a little, we can get stuff into frame here. Let's get you out of the way, we don't need that anymore. Okay, so here's my little Arduino Metro. I bought this from Adafruit.com and programmed it with a strand test. I won't go into the details of that. And then I have these little jumper cables. So I'm putting white on the ground. Putting red on the 5-volt. And I'm putting one on the 6 pad. And I'm picking 6 because that's the data pad, just like we do with Profi, where we have data 1, 2, 3, 4, and 5, and 6. No, maybe just through 5. Well, I guess technically 5 and 6 are RX and TX. But the strand test has been programmed to use pin 6. I could change the code and reprogram the board and use any other of the data pins. I mean, there's 13 of them. And then I have some alligator clips. So now I'm taking my alligator clip, which is green, and I'm connecting it to my jumper cable and my white data pad, data line. My white data line, which is going to pad 2, which is going to control the 5 on board. And now I'm taking a red alligator clip, I'm connecting it to my positive, and then taking a white alligator clip, connecting that to one or both. We can do both because why not? Okay. One or both. We're dealing with low voltage here. Not a lot of pixels. There's not a lot of current going through these wires. Just trying to keep that out of the way. I'll just hold it. Okay. So the board has an on-off switch, and it's powered by a 9-volt battery, which is already off. So if I turn that on, now I've programmed this to test blades, so it's set up for 130. But I could reprogram that for 5 pixels to just control that. So if I turn it on, I'm going to get red, and the program is just testing red, blue, green, solid colors. Takes a while because it thinks there's 130 pixels. But I should see blue come next. And then it's just going to go, it'll go white, it'll go rainbowy. You know, it's running through a series of tests to make sure that each of those pixels are working properly. And so I'm happy with that. I got all my colors, I got some of the effects, and that's all I was looking for. Just to make sure that what I've done to create this PCB is working properly. I can disconnect everything, and then I can put my tester aside. What I'll probably wind up doing is creating another tester, you know, buy another Arduino Metro and program it, one for 5 and the other one will be for my blades. The other thing we can do is I can put this into a holder that I have printed already. So I've designed these. This is a 1-inch version, but I also have a 7/8 inch version, and that allows me to drop Okay. And then I would glue the bottom here. I'm probably going to wind up redesigning this so that, similar to the TCS ones where it screws on, the custom Saber Shop ones, something where I can lock this in, whether it's using a screw or whether it's a piece that goes on the bottom and holds it in. But for now, what I've been doing is filling the bottom of this with hot glue. And that gives it... Oh man, my 3D print just failed. What's that all about? Oh well. There goes a 4-hour print. I'll have to come back to that. So now I can, because the test that we just did was only for the 5 onboard. But what about the blade? So this is my blade tester, similar concept, but that's a TCS, right? I could hook this back up to my tester. I have that. Now I can drop a 1-inch blade on top of that, align it properly, and just test a blade, make sure that the data 1 is working properly. But I don't really have a blade, and I don't really have something to hold the blade together. But that is a test I'll do. I'll probably just do it off camera, or just wait until I install this into the Saber itself that I'm going to build, and then test it that way, right off the Profi board. Because this one's a little bit more involved, just having to line those pins up properly with a blade. Not the end of the world, but just something I'm not going to do right now. Maybe I'll come back and do a part 2. And so that's, I think that's everything that I do for one of these. Some things that I've been thinking about as we've going through this. Is the flux the right? Just thinking safety, right? When you're using flux and you're doing soldering, you're getting chemicals that are coming up into the air. A lot of people use fans to move that chemical, that vapor, so you don't breathe it in. It doesn't go into your eyes. Maybe you use eye protection, put a pair of goggles on to protect your eyes, right? So, the point of the video wasn't about soldering safety, right? It assumes you know how to solder, and really it was more about showing you how to assemble one of these and then test them, and some tips and tricks that I've learned along the way. So hope that was helpful. Hope that was helpful, and any questions, comments, feedback, leave me some comments. Thanks, guys.